I'm sharing my PPT. 1 minute, ma.
Okay, sir.
Now PPT is also visible.
Sir, yes, sir. It's appear. It has appeared, sir.
Okay. Shall I start? Only 10 participants are there.
Yes, sir. You can start, sir.
Okay.
Still. Sir, there is an issue, sir. Before that, in the last week, Sumesh sir sent one PDF, sir, related about the batch.
Okay.
Previously, there were 15 members in A2 batch, sir.
Okay.
Morning, Nataraj sir has said that the group has redistributed again. So, 9 to 8 A3 students has to join our group, sir. That's why there's issue between that.
Okay. Okay. Means A3 batch means the diploma students, right? Yeah, actually in each batch, okay, A1, A2 or B1, B2, 20 members are there.
Sir, better you to give the new A2 batch list, sir. Then we.
Yes, Kushal. Yes, Kushal.
Sir.
Ah, okay. Shall I start, man?
Yes, sir. You can start, sir.
My voice is audible.
Yes, sir.
PPT is also visible.
Yes, sir.
Okay, ma'am. Thank you.
Okay, sir.
Yes, good afternoon, one and all. Jai Shri Gurudev. So today we are going to learn the subject. Not subject is a lab, computer integrated manufacturing lab, the Cim Lab, and subject code is 17 MEL 77. 17 means is a 2017 scheme. ME means mechanical engineering. L stands for laboratory. S7 stands for 7th semester, and another 7 is for subject, 7th subject. Is a 2017 scheme, mechanical engineering laboratory, 7th semester, 7th subject. Right? Now this is a Sim lab. Earlier we called a Sim and automation lab. Now we call it as a Sim lab. As PPT is visible, Kushal.
Yes, sir.
Yes, sir.
The
Yes, sir.
second slide is mechanical engineering, right?
Yes, sir.
Okay, thank you. So before going to start to know the Sim lab, again I'll come back to the what do you mean by mechanical engineering. Again, all the things are related here. So mechanical engineering is nothing but is an engineering discipline. It's a discipline or a profession. It enables to design, analysis, manufacturing, and maintenance of various mechanical systems. As you know that what are the mechanical systems are, take a machineries, engines, turbines. Already know about the mechanical systems or machineries. One is energy conversion devices. It may be turbo machineries, turbine, okay, or IC engines, boilers. Those are called as energy conversion devices. Next, energy transmission devices. Here, what type of energy transmit here? Mechanical energy transmitter, such as drives, belt drives, gear drive, chain drive, rope drives. And third one, uh, joining devices means locating devices that such as rivets, bolts and nuts, threads, screws, keys, etc. Or mechanical energy storing devices. The mechanical energy storing devices such as flywheels, right, springs, tension rods. So these are the some of the mechanical machinery, mechanical devices or systems you call as. Now, in those mechanical systems or this system, first in what the mechanical engineers has to do, first they go for design those system. Design is nothing but it is an art of creating ideas or concepts, expressing those ideas and form concepts in the form of plans and drawings to fulfill the needs, societal needs. That we call as a design. I think already studied about mechanical design or machine design. In the machine design, what you studied, you are going to assign the specification of machine element to withstand the load, right? Or to do its function. You are going to assign the specification such as a shape, size, material composition, and arrangement of parts. One is shape. What shape in nothing but is related to geometry. It related to geometry, right? Such as it may be what type of geometry is circular cross section, rectangular, a square, a triangular, or combination of others. Size related to dimension, such as a length, diameter, width, thickness, etc. Material composition and methods. Now the component is made up of which material? It may be mild steel, aluminum, copper, cast iron, or composite material. And methods are nothing but how the material is manufactured, how the component is manufactured. Okay, so it may be a primary manufacturing system or secondary manufacturing system. We'll discuss in detail. And last one is the arrangement of parts, how the parts are connected from one to another one in order to transmit the motion or power, or to it has to do its function, right? That process is called as a design, right? Okay, or in that machine design it is. Second one topic is, the first one is over design is an art of creating new ideas or concepts, expressing those ideas in the form of plans and drawings to fulfill the needs of a customer. Now the second one is, once you made a design of the component, then we want to engineers want to check whether the designed component is suitable for the task or not. How do you check? We'll go for in detailed examination or a tool we use. That process is called as an analysis. For mechanical engineer, usually we'll do the structural analysis. Means when a load is occurred on a component, consider as a component, when load is occurred on the component, how much stresses are induced in the component. Then we'll check the stresses induced in the component is less than the allowable or field strength of the material. Then you can say the design is safe. How do you say that? We'll go for detailed examination. The tool is called as a analysis. After once you made analysis, then we'll go for manufacturing. Then you go for design with the shape of the component, the size of the component. Once you give the drawing to the workshop, then what they will do, they convert the raw materials into semi finished or finished products. That process is called as a manufacturing, right? Now after the once you manufacture the component, then you give it to the market, then the customer has purchased, then you will go for what to do, maintenance the component, means to keep the component or machineries in a good working conditions. The how do you check? Periodically you go for inspect it or service it, then you say the go for maintenance of that component. So when you say mechanical engineering, you should comes under these four things. One, it is a discipline or profession. It enables to design the machineries element, analysis, manufacturing, and maintenance of various mechanical systems or machineries. Now you can see here some of the machineries. Now this is a what we call as a CNC machines along with the a robot. Second one is it is a engine, internal combustion engine. It may be BMW engine. Another one is mechanical power transmission devices, the shafts and the pulleys. You can see the belt which is rope over that, right? These are the some of the examples you can give the mechanical devices or machineries. Yes, this is what we explained here. What you may design, right? It is an art of developing new ideas or concepts, expressing those ideas in the form of plans and drawing to satisfy a particular need, right? So in every day we have go for in one way or another way we go for decision making process. The decision making process itself is a design. Next, we'll discuss analysis is a detailed examination of a designed component, whether it has to fulfill the needs of the to fulfill the task or not. How do you check with the help of the tool is called as a analysis. Next, manufacturing. It is a process of converting raw material into semi-finished or finished goods for use or for sale. Again, two types of manufacturing process are there. One is primary manufacturing process, means primary means whatever the raw material you get from the ore, from the okay in the earth, that is in the form of ore, then we extract it and make it a component, that is called as a casting, right? We heat the metal, we heat the the raw material in a liquid phases, then you pour into a mold, then you get the required shape of the component, that is a casting. After casting, go for metal forming, means forging, rolling, extrusion, drawing, sheet metal operation. These are comes under primary manufacturing process. After primary manufacturing process, again you need to go for further manufacturing unit, that is called as a secondary manufacturing process, such as by using a machine tools such as lathe, milling, shaping, grinding, drilling, etc. Right? Next, maintenance is nothing but once you device you have, keep something in the same state or at the same level. So how do you maintain it? Periodically go for check and inspect it. Whether it is not in a good working condition, then you go for repair it or services. These are different types of maintenance. In detail, we'll study when you opt for a elective related to a maintenance. Again, in mechanical engineering, based on these areas only we categorize here. Whether you go for opt elective for design related subject, thermal related subject, or manufacture related subject, or maintenance related subject, and one more stream will come, management. Okay, management related subjects. Yes, so Karthik E.
Yes, sir.
Yeah. Now what is the slide? What I'm sliding? The which slide I'm showing, man? Slide is visible.
Sir,
Check.
computer.
Yeah. Now is
Yes, sir.
manufacturing. Okay.
Computer integrated manufacturing.
Yeah. Thank you, Karthik. Yeah, now we studied only the what do you mean mechanical engineering. In that, what the terms it comes, how, right? Now it comes to our laboratory, computer integrated manufacturing. As you know that what do you mean by manufacturing? It is a process of converting the raw material into semi-finished or finished products for this for the use or for sale purpose, right? But during manufacturing here, so here the word is integrated here, word is attached here, computer, right? The use of a computer for the design of a product or plan the production or control the operation, right? So suppose in the workshop directly they will not go for manufacture the component. Before that they need a drawing, right? They need the shape of the component, then they need the dimension, right? In your in the third semester, I think third or fourth semester, also you are in the, yeah, in the what is it called, a workshop lab, right? Or machine shop lab. First you study the drawing, is for example in turning operation, then the lathe, right? Then you see the what shape it is, what is the dimension of that, the cylindrical rod it is, then how do you go for plane turning, step turning, the threading, tapering. Before going to the first you study the drawing and see the dimension. How do you get those drawing and dimension? With the help of the process you call as a design. Okay, design the product. After designing the product, what we'll do, so what are the operations you carried out to get the raw finished or semi-finished or finished product, then you go for make a set of plans. So for example, in the cylindrical object, you can see the first you go for plane turning. You can make into a 21 mm to 20 mm. There's a plane turning operation. Then you go for step turning, then taper turning, right? Then threading, etc. Then how do you? There's a final product is there. Final component is there. Before converting raw material to final product, what are the set of plans are there? That is called as a plan the production. After the plan the production, next you will go for control the operation. Controlling the operation means, suppose if I want to do a plane turning operation from 21 mm to 20 mm, directly we'll give that a 0.5 mm depth and will the plane turning. No, first we'll go for zero point 0.1 or zero point 0.2 mm or rough turning, rough plane turning, then you'll go for a finishing plane turning, right? We'll go for control the operation, and after that perform the various business related functions needed in the manufacturing firm. Business related means once you manufacture a component, then how do you make it business the component, then send that component to a market. In the market, how do you make that sell that component? First we'll do whatever the okay the product is there. Best example business related function means if you take any machineries, washing machine, or if you best example take a mobile. In the mobile, along with the mobile you can see the a brochure or as a what we call as manual. In the manual, they given the complete details about the component, right? With the two-dimensional view, with the orthographic or projected view of the component. That is called as business-related functions, right? In all these four processes or four action, what we use here, computer system we use. Then we can call it as a computer integrated manufacturing, right? The computer integrated manufacturing, it denotes the user computer system to design the product, plan the production, and control the operation and perform various business related functions needed in a manufacturing firm. That you call as a computer integrated manufacturing. In the computer integrated manufacturing, there are two things are there. One is CAD and CAM. CAD stands for what? Computer aided design. Only I'm using computer for designing the product. Means what you already studied in the first and the third semester. That is, you go for drafting it in using solid edge, or in third semester you go for creating the three-dimensional object and then go for assemble it. After that, in sixth semester, again you use the use of ANSYS software. You apply a load on that. Then how the stresses are distributed on the component. Means use a computer for the designing the product. That is called as a computer aided design. What is a computer aided manufacturing? Means use a computer only for manufacturing purpose. Means for perform the function related manufacturing such as process planning and numerically control the part programming. See then the definition itself here, Cim for apply only a computer for design the product, it called as a computer aided design. If you use the computer for the plan the production, control the operation, then you call as a it is a computer aided manufacturing. Yes, any doubt regarding a Cim? Yes. Momin Fazal. Momin Fazal. Yes, Momin Fazal.
Hello, hello. Sir, network lecturer. Hello,
What you are doing there?
hello,
Hello.
hello,
Momin
hello.
Fazal.
Sir, lag, sir, your voice.
My voice is
Hello,
lapsing.
hello,
Okay,
hello.
unmute yourself. Okay. Yes. If you have any queries or questions, right now ask in the middle of the presentation, or if you write down the question at the end of uh, the presentation, you may ask. Okay. Yes. Next one is automation. So automation is nothing but it is a technology concerned with the integration of the application of mechanical components, electronic devices, and computer-based system to operate and control the production. Then it called as a automation. In our what we use in conventional way, each time the operator will have to load the machine or unloading it. Then you go for a perform the operation. Okay, that is manually what we do. That is not a automation. In automation in the lathe machine is when you go for thread cutting operation, then it is called as automatically that the operation is carried out. That is called as automation. Suppose if automation are two things are there. One is automation of the manufacturing system in the factory, means converting raw materials into semi-finished or finished products. There we have applied the automation. Or second one is computerization of the manufacturing support system for manufacturing. Apart from manufacturing, what are the other things are there? Supporting elements are there that we go for controlled here. So In our lab only we concentrated here automation of the manufacturing system in the factory. Means when you convert raw material into finished product, there we go for integrate that, use this technology. There's a mechanical, electronics and computer based system. Okay, best example for give the automation. So in our college you can see the Nandi parlor, right? So if you want a coffee, or yeah, if you want coffee, so manually you go for prepare it, right? Apart from, we can see in the Nandi parlor in beside the society, one more device is there, right? The coffee making machine is automatically, it will make that things, right? That's a quite a simple way, it is automation one only. Now that automation is we applied only for manufacturing system, right? That is only we study here. It operates in the factory on the physical product only, means converting raw material into semi-finished or finishing product. That operation consists of three things. One is it may be processing, converting, or it may be assembling, means the joining takes place or assemble one component to another one. After assemble, then you go for inspect it, we check whether it is good working conditions or not, or it may material handling. For these three process, you will go for use the automation for the manufacturing system. Then why do you go for automation here? The automation is because they perform their operation with a reduced level of human participation compared with the corresponding manual processor. That's why we go for automation. Then some other reasons also there. Reason for automation, okay, that we'll discuss in later. Then different types of automations are there. There are different types of automation. One is fixed automation, second one is programmable automation, third one is flexible automation. So whatever the automatic things were occurred here is a fixed, means there is no change in that process. There is no change in control the operation, or what is second one is there. There is no controlling. Yeah, there is no change in control the production or operate the production. Okay, that is his fixed one. For example, if you take a lathe machine, if you want to do the a thread cutting operation, the carriage has to move from right side to left side only to cut the to do the thread cutting operation. There is no change here. Only can change only what here? Only the pitch of the thread we can change here, right? Based on that, by changing the gear mechanism, right? Now in the programmable automation, we'll go for whatever the instructions are there, the operations are there, we can slightly change. We can change that operation. That is called the programmable automation. In flexible automation is an extension of programmable automation only. Okay, there are some advantages and disadvantages also there. What are the advantages and disadvantages? We can explain in three ways. One is a product variety, second one is a cost nature, and third one is a production rate. First one is product variety, second one is cost, and third one is the production rate. What is the product variety means? In fixed automation, the product variety is not occur, it's a fixed only. Second one, cost of that production is also less, but equipment is more. The cost of the equipment is no more, but cost of the product is less. Okay, the second one, whatever the last, production rate, the production rate is more in the fixed automation. Clear? When it comes to programmable automation, in programmable automation, product variety, there's so many varieties of product we can get, but cost also more. Whatever the number of product we can manufacture is less. In flexible automation, there is a in between the fixed and programmable automation. That is, the product variety is also more, the cost also more, the production rate is also more. That you can see in the next slide. See that this graph shows. This graph is visible, Kiran M. Kiran?
Yes, sir, it is visible, sir.
Yeah, there's a
Yes, sir, it is
slide.
visible.
Okay, man, thank you. See in the graph, you can see that x-axis shows the production quantity, production rate. Y-axis shows product variety or variability it is. See that first fixed automation, you can produce a number of product but the product variety is less here. Second one, you can see the programmable automation. The production quantity is less, but variety you can get more. What is a flexible automation? Best example of flexible automation is flexible manufacturing system. There you can see the product quantity also more, variety also more. Now you can see the in any industry you can see this flexible automation only, means flexible manufacturing system. Now in our lab is related to only a programmable automation. Programmable automation. See, the programmable automation is a production equipment designed with the capability to change the sequence of operation to accommodate different product configuration. Okay, such as what are the different program automations here? You can see the NC machine tools, CNC machine tools, industrial robots, and programmable logic controller. These are the programmable automation. In our lab also we use this type of automation, programmable automation. Now reason for why do you go for automation or automating means, one is to increase the productivity, means the number of output per hour from the input should be more. That is the one. Second one, to reduce the labor cost. Third one, to reduce the effects of labor shortages. Now, then fourth one, to reduce or eliminate routine, manual and clerical tasks. Fifth one, to improve the worker safety. Sixth one, to improve the product quality. Wherever the intervention is there, difficulty is there, then you go for use the automation. First one, main thing, you have to increase the production rate, improve the product quality. Third one, reduce the labor cost. Then fourth one is what is it, wherever the human intervention is not possible for during manufacturing, there you can use this automation, right? Next, now in the we have only what is a programmable automation, and in that numerically controlled machine, NC machines are there. What is the numerically controlled machines are there? It is a programmable automation. The mechanical action of a machine tool or other equipment are controlled by a program. Program is nothing but a set of instruction given by step, a block by block, a set of instruction given. That is called as a program. Now, how do you write the program? That program contains alphanumerical data. Alphanumerical data means alphabetic A to Z letters and 0 to 9 numbers. That's called as alphanumerical data. Means if you consider a machine, the cutting edge, the workpiece, I want to move the cutting edge over the workpiece. That's called as controlling the operation. How to control the operation? With the help of alphanumerical data. Okay, that is where we use is a numerically controlled machines. Numerical control is nothing but is a programmable automation in which mechanical actions of the machine tool, the movement of the machine tool or other equipments are controlled by a program containing a coded alphanumerical data. Okay, the alphanumerical data represents relative position between, these are two important. One is cutting tool or is also called as work head. Another one is workpiece, we call as work part. The cutting tool and another one is workpiece. The cutting tool now we call as a work head here. The workpiece we call as a work part, right? There is a relation position between these two. How do you give the relative position between these two? With the help of a program. A program contains a set of instruction in the form of alphanumerical data. That is called as numerically controlled machine. In the what is the fundamental things in the numerical controlled machines are there? These are three basic things. First, basic components. One is a program, a set of instruction, a block by block, a line by line instruction. Second one is a machine is there here, processing machine. It may be a turning or milling machine. So if a program is there, machine is there, then I want to interact between these two, connect between these two with the help of a component called as a machine control unit. The machine control unit is nothing but is a hardware code unit, or it may be a computer, mini computer. If it is used only a hard code wire unit, then it is called as a NC machine. Instead of machine control unit may be a computerized one or microcomputer, then it is called as a CNC, computerized numerically controlled machine. Clear? These are three basic elements in a NC machines or NC technology. One is program, second one is machine control unit, third one is processing equipment or machine. Okay, then next one is NC coordinate system. So you know what is the NC coordinate system? Based on that workpiece. Suppose it's a rectangular workpiece, I think is visible. Here, Karthik, this is a, yeah, this is a notepad is visible, right? This is a what type of workpiece it is? Assuming a workpiece, it is a flat or a prismatic workpiece, work parts. Now, how do you define this workpiece? One is the x axis, another one is y axis, and the thickness is called as z axis, right? Similarly, another one is a cylindrical component. Take a pen here, cylindrical component. It has only two coordinates. One is the diameter, another one is a length, that is called as z axis, right? So here for machine, what type of machines we use? Suppose if the machine carries a flat or prismatic work part, we have a three coordinates. That's a linear coordinates. By applying a right hand thumb rule, thumb shows x-axis, forefinger shows y-axis, and middle finger shows z-axis. Okay, by applying right hand thumb rule. So work in the milling and drilling machine, whatever the workpiece is holds here, workpiece is fit in x and y axis. The cutting tool come and place its perform here in z axis. That is called as a flat and prismatic work part. Those are the linear coordinates. Apart from linear coordinates, the you can see in this sketch here, A, B, C, the rotational coordinates are also there. Again, apply right hand thumb rule. Thumb shows axis, the fingers are curved. That is shows the direction of rotation of the workpiece, right? So now this is the x-axis here. The fingers are curved here. That is called as the rotation about x-axis is A. Similarly, rotation about y-axis is B. Similarly, rotation about z-axis is C. These coordinates are used for a flat or prismatic work part. Similarly, go for a rotational part. Rotational part means for turning machines. We have required only two coordinates. One is along z axis, another one is the x and y is coincide here. That is we use only x coordinate. That is again apply right hand thumb rule. The thumb shows z axis and the forefinger shows a x or y axis. X is equal to y because the radial direction is a cylindrical part, right? Now these coordinates are used for in NC machines. Next, motion control system. What is a motion control means? For example, I want to move the cutting tool over the workpiece. There are two types are there. One is for drilling operation. How do you do the drilling operation? Move the cutting tool over the where you want to do the produce a hole here. Then you place here. Then produce make a hole and remove it. That is called as what here? A point to point positioning, or also called as a positioning point to point or positioning coordinate. Or in for end milling operation or in turning operation, what we'll do, we'll go for a continuous path. So once you is a whatever turning rotation you move the cutting tool is a continuous path. It may be a straight line, or it may be a curved line, or it may be a combination of the straight and curve. There's a curvilinear. These are two things are there. Okay, once the meeting exists, again rejoin that meeting. Okay, again I want to continue that session. Clear? Yeah, the motion control systems are one is point to point